speech acts in the brain. Can you tell us that?
I'll try to if you allow me to well, I'm going to have speech acts, and I'm interested in two aspects of speech acts processing, which is handwork and physical correlation, where semantics happens in writing. And I'm going to address this question in terms of meaning and request, and also looking into semantic differences between the words to clarify some of the handwork hypothesis. So what's the speech act? The speech act is sentence being used. So when you, for example, hear somebody say coffee, it can be this is coffee, or I want this coffee, or, well, in either case, one single word without the impact, without the semantic impact of complexity, how the word is really large. And naming and request are very different speech acts in that naming is more or less naming and labeling an object versus request is labeling an object that you want, means labeling the object that you want somebody to give you. Therefore, you expect an action in response, and you also expect some reaction, maybe emotional reaction on the part of the agency. So, in this respect, we can expect more activation to request than to naming in the brain. This can be caused by the fact that more complex brain networks are recruited. For example, it's going to be action, observation, action, expectation, so that's a motor or communicative network. With regard to the time word, there is no particular framework that describes semantic processing at the minute. So there are two major linguistic processing, general linguistic processing models, one of which is a cascaded model, which presupposes that each level of linguistic processing comes after one another. And for example, semantic processing and then semantic processing being the higher order one. Then semantics is not expected until at least 100 milliseconds after the concept of the word, for example. And there is no interaction between semantics and semantics. Not even at 400, but let's say for sure not before 200 milliseconds. The other model also does not claim anything about semantics, but presupposes that as soon as you get information about semantics, you also get information about semantics. So you have all the information available from the very beginning, and therefore you expect an interaction between different levels of linguistic processing. And you can, for example, have an interaction between semantics and semantics for two continuous. So in order to address the question of time work, we ran an EEG experiment, and let me get to the so there were two people in the video, and in one case there was a naming context, and for example, the person on the right asked, where are these balls? And you can see the object on the table, and the other person would say, or other participants would say, I thought the word visual event for 150 milliseconds, plant. So in this case, it would be a business plant. And in the other case, the question would be, what can I get you? And again, the participant would see plant after that. But in this case, plant would be a reaction to a question, a request question. So plant would be a request. So we compare this one word, so identical stimulus, in this condition. So we only manipulate the context, and then we can see whether there are differences in a single word level, whether there are any semantic differences. As I mentioned, we use different kinds of words in order to tap into semantics, and we want to look at when semantics happens and when grammatics happens, and whether there is any interaction. And we know a lot about semantic processing in general, thanks to Ilya and Friedman, who explored this into much detail. So categorization, semantic categorization normally takes place about 180 milliseconds, and 150 to 200. That's about what we do. So the stimulus were matched on the number of psycholinguistic variables, and you can see that they are quite closely matched. So we obtained global field power curve to the two conditions for all the participants in the channel, and that was the way for us to determine which time windows we were going to analyze, because we didn't want to have an entire hypothesis as to when chromatic should happen first. So in that respect, we were very open and very surprised to see that chromatic first peaks some difference with some arrive already at 110 milliseconds to 130 milliseconds, and then there are other time windows 125 to 185, 250 to 335, and 445 to 540. So we then did statistics analysis on this kind of windows that we developed, we determined by looking at the average score. We also have some topographical hypotheses about where it happens in EEG as well, and therefore we ran topographical analysis, which included some variables like interiority, anterior versus posterior, left versus right, and central versus peripheral. So central versus purple for circles and the great circles are curved. So in the paper, there is the argument about the bias of the method. We did not find any difference between the conditions, and we did not really expect them, because we hope that our stimuli in both conditions will be equally complex or easy to be dispensed. Therefore, there is no difference in accuracy or in reaction time between the two categories. However, in the brain, we do find differences, and this is the global field power. You saw one curve because it was all the conditions put together. I want you to look for the red versus blue in this slide. So basically all the red curves that you see is request, and those blue ones are the name. And you can see that consistently there is more activation to request than to name globally on all electrodes for all the participants. And this is the good. Then we decided to look into particular time windows that you see. It's really unfortunate that you don't see it. Sorry. So here you have six, and we will analyze each week, but not globally, but with topographical factors taken into account. So the topographical, so the first time window, 110 to 130 milliseconds, very early time window, well before the Edelman effect, and we can see that there is a main effect of chromatic. So the red one is request and the blue one is main. And again, request is more information than main. So here you can see that the upper one is naming, the upper row, and the lower row is request. And the columns are non-hand-related and hand-related respectively. Another finding regarding the same 110 to 130 millisecond time window is that there is an interaction between chromatic, semantic inferiority, and neutrality. And again, we see this request is bigger than naming, particularly at the anterior central electrode, and there is a dependency on which category it was in. So anterior central in the non-hand category and anterior peripheral in the hand category. But what's important is that there was a dependency of chromatic on semantic. And that's important for our prediction. In the second time window, in accordance with the previous findings about semantic categorization happening in this time window, primarily, we do find, even by looking at this topographical map, we can see that the difference between the upper and the lower row is not that great, but the columns are different. So here, there is much more central activation in the hand-related class than in the non-hand-related class. And it's expressed in the six-hand process on the right. Again, in the second time window, we find an interaction of chromatic and inferiority and centrality. And again, it is important because it happens the first time in a second, and already there is an interplay between chromatic and central. In the third time window, we found one lateralization effect in that chromatic, again, request was bigger than naming, but only in the left and not in the right hand. And the fourth time window, there was only a marginal significant effect of chromatic at the anterior side. Again, request was consistently bigger, the response to the request consistently to naming. Well, then we wanted to look at where our activations are coming from. The topographical map tells us that is anterior ventral. More specifically, we looked at L1 first reconstruction theory, and it's probably difficult to read, but the idea that we could single out certain areas, for example, or certain networks, which are more or less meaningful in terms of our hypothesis that the original prediction. We do find motor activation more in request than in naming. We do have interfrontal gyre activation, again, more also present in naming, but more increased in request. We also find certain instances of right temporal junction activation or bacteria, very temporal activation, again, for request. Interestingly, we do find that naming was more consistently activated in the temporal areas, more activated than request. So it wasn't only request bigger than name, but also naming bigger than request, but in very certain areas, like the temporal areas. So to sum up, our EEG results show that request in amplitude, request is always bigger than naming. Speech exposing starts already at 110 to 130 milliseconds, which is a very early effect, but we believe that it is quite possible that it takes place in this time. Then there is an interaction between semantic and sympathetic factors. So that with the 3 points would point to the near simultaneous model of linguistic protein. Then we also find some graphical things like the affiliation is more interdimensional. There is no specific lateral pattern except for maybe lateral elevation for request than for naming. And then we could spin down several networks in our first reconstruction. However, EEG is not very good for a lot of things, for example, trying to say something about where processes happen. Therefore, we ran another experiment, which was more related to the localization hypothesis. And again, there are lots of discussions on the fact that fragments should be on the right or bilateral, that it could be distributed or localized, meaning that there is a hub that is only engaged in fragmented processing, like broken bearing, and there should be another maybe blob in the right hemisphere that takes care of fragmented processing, or in the interior type. So we take this into account, and then we run a similar experiment, this time a voluntary experiment, and we, to make it more MRI, we make it more useful for the MRI. We made this as a block design, so we had 5 photos in the row, and then we had 5 actions following. So again, the same identifier, we analyze the same words, and then we compare them into different conditions. But we see, since it was the auditory presentation, here is all the words, both naming and request, minus spaces. So if you remember, here is the word, so here is the space that says something, right? We minus the space that says something, we subtract the space, and here is what we see. In red is the relation to the word, and in blue is the activation induced by spaces, looking at spaces. So here you can see that it's not the temporal, including the partial gyrus, and also middle temporal and temporal. So the right angular gyrus, but then we had our hypothesis between the words, right? So when we made the subtraction request words minus naming words, here's what we see. And what you see is a lot of activation in the occipital area, which is probably trying to predict what, or have visual association with certain words to a greater extent for representation. Importantly, there is, again, the motor activation in the hands area, which was more amplified, let's say, in the condition of request rather than the condition of naming. And then we also can see, well, probably not that clearly, but there is this activation in the left anterior frontal gyrus. Again, very much like in the first reconstruction that we've seen in the EEG data. However, more refined because it was, well, cleaner design for the MRI and all the good match. bigger. I would like to say that when we did the backward subtraction of main minus request, we did find some activation, but it did not provide the statistical threshold. The SDR corrected it did not secure on the map anymore. However, that allows us to have a look at the ROI activation analysis. And here, you should remember, we have three major networks that we want to find or not find. And the coordinates for this network is provided by received by overall in 2010. So we took these coordinates. So this is the chemical chart, general coordinates. This is angular chart, interior quantum chart. Again, know the activation above zero. There is this is CTJ temporized, this is Britania, activation at all. Middle prefrontal, and then premotor cortex, and there are integralized also, and the premotor cortex, and here with bacteria is very simple. So I'll show them in a second. But note the fact that mostly the mirror action system got activated, and also the manual system in the middle frontal cortex. I would like also to draw your attention to the fact that, for example, the name was bigger in the linguistic network in the temporal area, whereas request was bigger in the interfrontal cortex, the traditional plasma area. So, to zoom in, looking into left and right within this area. So here in the request, in green you can see the one-time test, which were different from zero. So this is activation. And in yellow these are the regions which got activated but not significantly. So we see activation above zero but not really big enough. So here for sure there is no further activation. There is superior temporal pulses, then left inferior frontal gyre. Note that there is both left and right. It's on the left there is more activation, and it's both frozen areas with 4 and 25, and on the right on the left but less strongly the 87 as well. And all the temporal areas, all the 20 so inferior and middle and superior temporal gyre, all of that is activated. Well, summary of the MRI results shows that maybe the pragmatic system indeed keeps on organizing in terms of network rather than a particular hub, like contextual integration hub. Indeed, different features between specific areas and specific areas actually reflect the meaning. Because in naming it's important to retrieve the label, which is broadly speaking part somewhere in the semantic area, and with request, which is action specific and social, there are more communicative and motor areas that need to be activated. And we did not really find any particular localization pattern. So everything is more or less bilateral. And that just suggests that distributed pragmatic network rather than a pragmatic hub is a more relevant model for pragmatic programming. So the final thing is that, again, in terms of time network, we have early pragmatic effects. We have semantic and pragmatic interaction before 200 milliseconds, which supports the near-range simultaneous model. And we have consistently request more than naming amplitude. And we see that it's a number of networks rather than a particular area that's responsible for pragmatic enrichment. So these are things that I would like you to remember. And if you have any questions, I would be happy to answer them.
Yeah, very interesting talk. Thank you very much.
Share the light.
I actually just your analysis of the EEG data.
Yeah.
So how did you determine the time window of interest? Because some of them were really, really quick. So would we call that a time window, but rather time stamp or something like that?
That's true. So in terms of the time window, first of all, we had this global peak hour curve that we determined the peak here, and then we took 25% of the peak or the quartile of peak, and this is the time window, that the interval actually that we are considering. So from peak, 25%, and then the peak time window. The reason why we...
And those peaks you only determine by eyeballing the averages, or...
Well, so for example, there is this, there is a special command in English that allows you to detect peaks automatically. I wouldn't say that it's automatic, but it tells you where the peak falls, and then you can more or less believe that. In terms of, so we could have analyzed some other peaks, or was there some differences based on the eyeball, and I can tell you that, for example, in the curve, this difference is actually probably big, and it is there, but we only concentrated on the peak. I can also reassure you that all that happens before 100 milliseconds is not significant. I checked that as well, so statistically no differences, although we have some bumps. So basically, the way we decided to go with is to be as objective as possible in determining the peak, and for me personally, it is important because if we do not have any hypothesis, I do not really believe that we are allowed to take n for 100 effects, which does not mean anything to me. So any component is just reoccurring, but there is no real function behind it, or with a specific function, and localization either. So if you do not have any hypothesis behind it, then probably be as objective as possible. And since the first more or less study that tries to consistently determine the time course of dramatic processing, I thought that was more or less objective. Another thing is that we are well aware of the fact that our presentation was blocked. So prediction could play a role. So we have very consistent, determined, unambiguous context. So that would speed up the processing, just because you know what to expect in the next 10 words, right? So as soon as you get the context sentence, all the words that will follow will have the same type. So therefore, we are now planning an experiment which will actually challenge that, the predictability. And then we'll be able to say more about when it starts being unpredictable or less predictable.
Sure. So here's my question. Actually, it's two questions, but they are related. So I understand that you bring more evidence for the very early facts that report that we go from inverse conception, electrical access, and stuff. My problem when you have this four peak space and you come in very early. So the first part of my question has to do with, are these separate processes, or is it the same process that your effect, your experimental effect, do they represent the same process that peaks several times? If not, if these are distinct processes, which it seems to allude, it feels like. So what kind of early pragmatic process, how different is your 100 millisecond pragmatic effect from 400 milliseconds or 600 milliseconds? What do they do these things?
Okay, so I think the best way to answer this question is to run an MEG experiment, which we are going to do. So we want to map the peak and the brain activation, and we sort of do that in the reconstruction, right? And here you see that, for example, the motor effects appear already in the first and in the third and in the fourth time window, whereas, for example, the effect with CPJ and the series, yes, it appears on the later. So I do believe that these peaks represent different processing, but that is just my hypothesis. Another thing is that basically the early effects, again, in certain papers, the right CPG is found deactivated at around 150 milliseconds when we need to determine it's called intention recognition, intention inferencing with traits, without traits, conscious, unconscious. But it does happen at 150 milliseconds after the presentation of the word. And this is related not to linguistic processing, but rather to immediate intention recognition. So it's goal-directed behavior studies.
Something like that would be your candidate explanation for the effect.
Sure.
Well, that pretty much answers my second question, which has to do with the EEG data on one hand and MRI data on the other hand. And of course, one is inferior in terms of localization, the other one is not that good temporally. You don't seem to strongly suggest that the networks you're showing from MRI are analogs of your effects from EEG because they're temporarily not properly aligned.
No. As I said, the best technique would now be to...
Yes,
understand that this EEG reconstructions over there slightly, slightly less clear. But on the other hand, I do believe that if we find both there and there, and this is with different auditory versus visual presentation, it's something that is representative of chromatic processing of this particular speech act in general. So I wanted to show you the convergence of this evidence. On the other hand, this is still a question that needs to be discussed. And,
there is one short question with short answer, then we will take it.
My question is not short, so.
May I just ask one short question? Because I have a short question. Well, short one would be, so it seems that, so I'm wondering why you received this fast effect of cosmetics so early. Could it be because of the onset? I mean, both in both cases, I mean, in the native condition and in the request condition. So it was an answer to the question, and probably this was because of that, or the other possible explanation would be that the context was already introduced in the question, right? And that's why I mean, absolutely.
And the main difference that you had between the two situations was not, mathematic difference, but just arousal difference. Because the pragmatic concept is much more arousing than the naming concept. And so you have your difference from the very onset of singular presentation and no kind of specificity in your data. That's my
Can we stop here and take it one slide? Because I think we're trying to stay on time and we're nearly on time, which is great. So I think the organizers will now take us to a place where we can eat and things if we manage. So let's come back at 1, 2, 3, right?